want to talk about first is not a new type of factoring, but it's a special type of trinomial factoring, where when you factor it, the two binomials you get will be identical. If you are asked to factor a trinomial and it factors to two identical binomials, we call it a perfect square. Trinomial. Do you remember what perfect squares are? Like, what would be a perfect square number? Why? Exactly. Okay? A perfect square number is a number that can be written as another number times itself. So 4, 2 times 2. 3, 9, 3 times 3. 100, 10 times 10. Well, algebraic expressions can be perfect squares too if we can write them as some expression times itself, which these are. So, like I said, this is not a new type of factoring. You guys know how to do this. It's just the answer looks a little different than what you're used to. First of all, what are the three types of factoring we know? X squared trinomial, GCF. Excellent. Okay, what kind is this? It's an x squared trinomial. That tells us the method we can use. So it's going to go to two binomials. The first term in each binomial has to be x and x. And the numbers will have a sum of positive 6 and a product of positive 9. What two numbers fit that? Positive 3 and positive 3. Well, if we've got a binomial times itself, the easiest way, simplest way to write it would be x plus 3 all squared. What kind of factoring is the next one? Right, so we can't use this method. We can't use sum product. This is where we got to do the rainbow thingy. Okay, these two must multiply to get 25x squared. Give me a pair. 5x, 5x. So I know that's going to work if I multiply this through back to here. Two numbers that multiply to positive 4, but if you look at the original, there's a negative in the middle. What do you think? They're both going to be negative because when I multiply them, they're going to be positive. So give me a pair. Negative 2, negative 2. I know that works. I just have to check to see if I multiply this back through, would I get negative 20x? And this is where we use the rainbow. And we multiply the outside 2 to get, and we multiply the inside 2 to get, and when I put those two together, I get works. But in this case, like the previous one, the two binomials we got were identical. So the simplest way to write it is 5x minus 2 all squared. Okay. Okay. Here's the last type of factoring. And what we call it is a difference of squares. That's the name of the type of factoring. How do you recognize the difference of squares? Well, kind of the way it sounds. What does difference imply in math? Subtraction. And squares implies perfect squares. So to identify a difference of squares, it's two terms. Each term is a perfect square. Separated by a minus sign. Okay. That's how you recognize it. So for example, here's one. That's a difference of squares because it has two terms. A squared is a perfect square because I get to a squared by doing a times a. B squared is a perfect square because I get to b squared by doing b times b. And they're separated by a minus sign. Okay? When you factor it, it will always be two terms. One will be plus, the other will be minus. The first two terms will be the square root of the original first term. The last two terms will be the square root of the original last term. And the reason why that works is if you multiply through, so you do a times a to get a squared, a times minus b to get minus ab, b times a to get plus ab. I'm going to write it in the same alphabetical order as the previous one. And b times minus b to get minus b squared. Those will cancel out, and you're left with a squared minus b squared. So all you have to do, here's a couple of difference of squares. Two binomials. Always plus minus, always. The first two terms will be the square root of x squared. What times itself gives you x squared? X times x. The last two terms will be the square root of 25. That's it. That's all you do. So this last one, two sets of parentheses, plus minus. What would be the first term of each? 4x, because 4x times 4x is 16x squared. What would be the last two terms? 7y. Done. Yep. You can't because they're not the same. Good question. Very good question, actually. Because students will often do that. They'll see a difference of squares and they'll think, oh, I can write it as this squared, but you can't because they're not identical. One has a plus, one has a minus. How would you factor that? What was it? How can we always check to see if we factored correctly? Multiply it through, right? So we get a squared minus 6a plus 6a minus 36. And I get my previous answer, don't I? No, I don't. In order to be a difference of squares, these two have to be perfect squares. And what else did I say? It has to be subtraction. It has to be negative. You can't factor this because it's a plus. It won't work. Okay? It has to be a minus. And that would be like, even if I asked you something like this. How would you factor that? You can't, because this is not a perfect square. What times itself gives you a? Can't factor. Be careful with those. Be on the lookout for that. Okay, so that wraps up the factoring. We've got 4 types now: GCF, x squared trinomial, ax squared trinomial, and difference of squares. So what I would like you to do for Tuesday, please,